Hey everyone, I'm happy to see all of you, even it's remotely. My name is Victoria. I'm the Senior Security Solution Architect in Microsoft, based in Norway. And today I have the pleasure to have with me Lars, who is a Senior Cloud Solution Architect at Elasticys. And he feels like a fish in ocean when it comes to the cloud, and he's amazed about the Kubernetes. Nice to see you, Lars.
Nice to see you too, Victoria. Hi, thanks for having me.
So how do you feel like how's the things are going today?
Oh, everything's going super nicely. I mean, it's such a wonderful day, and I've been looking forward to this conference so much. So it's really, yeah, it's wonderful that it's here.
Yeah, it's kind of amazing, like that's so remote conference, but at the same time we meet each other, and it turns out that we are neighbors. Like you're in Sweden, I'm in Norway, and not so far
Yeah,
away from each other. It's
no, exactly.
That's really good. So, and we're working in the cloud. Sorry, we're working in quite close areas. Like you are the cloud solution architect, and same goes to me, except that I'm focusing a lot from the security perspective. And I guess
Yeah,
that's a reason why I'm as well excited to be here, because you're going to speak about the security as well today. Can you give it
yeah.
maybe the teaser bit? Why security? Why Kubernetes? If you love the cloud.
I do love the cloud. And I mean, I think that Kubernetes has managed to do what no other technology has managed to do before it. So when cloud started, say, what, 13 something years ago, roughly, a bit more, I suppose, um, we had all these different clouds. They weren't compatible with each other. So if you had, developed for one cloud, it would be next to impossible to move your deployment to a different cloud. Now, Kubernetes has totally leveled that playing field. So you can deploy to Kubernetes, and it's going to work the same basically in this cloud or this other cloud, and that's wonderful. So I think that's really cool, and that it's also not something that requires a cloud by, say, one of the big three vendors, but you can actually install it on your own machines as well, and it's going to feel like the cloud. Okay, so I think that's wonderful. Now, the problem, though, is that Kubernetes, together with, also like, say, Docker before it, basically say, security, what's that? And that it's sort of this optional thing you can add afterwards rather than being the default. And we all know what happens to things that are optional, right? I mean, you don't enable them.
It
So
is.
that's a big problem.
And it's like, you can't follow the false assumption that if it's in the Docker, it's secure, right? You need to think
Sure.
about that the security as well. And
Yeah.
I'm so excited to see your talk. But before we jump to that, I want to remind everyone that feel free, please write your questions, and we will going to address them once
Yes.
Lars will present all what you have on your plate. So I guess the stage is yours.
Thank you so much. Yes. All right. So, yeah, I see that people can see my slide now. Okay, so welcome to this talk. It's about securing Kubernetes container platforms in 2021. And as you see, I have a subtitle here, the NSA slash CISA Kubernetes Hardening Guidance and Beyond. So, um, in August of this year, the NSA and CISA, two American agencies, they released a hardening guidance tech report. I will talk about that, but I will also go beyond that because I've been working in this field since, well, 2008. So who am I even? Why should you listen to this talk? Well, so my name is Lars, as Victoria said, and I've been in cloud computing since 2008. I have a PhD in computer science, and I have tons of years of experience in software engineering and in DevOps. And now, as Victoria also said, I'm a senior cloud architect, and I also work as an expert DevOps engineer at Elasticys. And we make something called Compliant Kubernetes. Now, this is not going to be a sales pitch in any way. When you get these slides, I think you can download them from the conference website, right? So by all means, do enter these slides and click on that link. It's an open source project. It's something that we put together. It's a Kubernetes distribution with all kinds of security features enabled right from the start. And if you'd like to, then please connect with me on LinkedIn. I post about stuff related to security, obviously, Kubernetes, DevOps, and also compassionate leadership. So if those things are of interest to you, then please connect with me on LinkedIn. All right, so to frame this talk, here's an uncomfortable question. So what permissions have you given me in your Kubernetes cluster or cloud infrastructure if I manage to hack into your application? Most people that I ask this question to get a bit sweaty right now. And if that describes you, then this is exactly the talk for you. So by all means, stick around. So the outline for this talk is, first of all, let's talk just briefly about the different threats against your system, against your Kubernetes cluster, against your application. Then the first part is going to be about the NSA and CISA Kubernetes Hardening Guidance. I'm going to summarize and explain what it's about, but I'm also going to add some of my take to the various headings as well in there. And then the second part of the talk, or third maybe, is going to be about going beyond the NSA and CISA recommendations. All right, so let's start with the threats. So the uncomfortable question was about me hacking into your platform or your application, but that's not all. So it's not just about external hackers. That's actually just one possible threat here, namely the middle one here, the malicious threat actors. So these are like the outside threats. These are hackers. These are automated attacks. We should also keep in mind, depending on how sensitive the information is that we work with, the supply chain risks. So you obviously deploy your Kubernetes platform to, say, a cloud provider, or even in your own basement or whatever, to hardware that you own. But all that hardware and software that is running to make that experience possible for you is supplied by third parties. And who here, well, I guess this isn't an interactive call in that sense, but many here probably recall that big Bloomberg article from 2018, about the super microcomputers. The company that, according to Bloomberg, had a supply chain hack by Chinese authorities, with the like tiny chips that were like a fraction of a grain of rice or whatever big, that were supposedly added to computers. It's still not proven if that happened or not. So I don't know where they got that information from. And honestly, I don't even care at this point, because the point is it could happen. And if you have sensitive enough data, perhaps someone in the audience actually does have that, then please, you should probably think about that. The thing is, though, so that's about hardware, and that's a bit more, I don't know, it's not that big of a deal to many people. They think that, yeah, that's going to be fine. But you do run third-party code all the time, though. So I'm sure that you, like many people, just install operating systems. You get all kinds of containers from all kinds of places. You just deploy them. So you do run third-party code all the time. And can you trust that? Are you entirely sure? I'm not entirely sure. I at least want to scan those things. So let's talk about that in the upcoming part of this presentation. Now, the third type of threat is, of course, the insider threats. So these are your internal users, and they have legitimate permission to access your systems. And they can either be intentionally malicious, or they can be coerced, forced to by outsiders to actually do things to your system, or tricked, And it's also important to note that there are statistics that says basically 2/3 of all insider incidents are due to negligence. So if we would have systems in place that would prevent insiders from doing something they shouldn't, we'd be in a much better position than we are by default, where basically anything goes. Right, so let's go to the NSA CISA Kubernetes Hardening Guidance then. So what even is it? Well, it's a 59-page tech report, and it was published publicly in August of 2021. It's focused entirely on Kubernetes itself. All right. So there are detailed discussions of security-related configuration. It goes quite deep. So it's actually talking about, like, these are the ports you need to open between worker nodes. These are the ports you need to open in your firewall to blah, blah, blah. There's also a whole bunch of example code in there. So it goes very deep. It does mention other security software in passing, but one thing that I find is problematic with it, by the way, if you want to read it, you can just click the underlined link here in the presentation if you download it. My main problem with it is that it focuses mainly on hardening, obviously from the title, right? But security isn't just a one-time thing. It's a process. So you can't just go like, yep, I hardened my cluster, I'm fine. So you need to keep it, you need to have security as a continuous process that you keep working on all the time. Because new threats are always going to be developed. And if somebody does actually want to hack you, they're probably very determined to get you. So you can't just relax. All right. So the first point in the security guidance is that they say that you should scan your containers and pods for vulnerabilities or misconfigurations. Okay, why? Well, first of all, let's just briefly remember what container images are, right? So the whole point of them is that they are supposed to be this immutable packaging of software, right? So once a container image has been made, it doesn't change. And that's the beauty of them. So that's why we love them so much. We can take the same container image and we can, have it developed in our dev environment. We test that exact image in our test or quality assurance environment. It goes to staging, it goes to production. No changes, maybe some configuration changes, but no changes to the underlying software. That's why we love those containers so much. Now, the problem, of course, with something that doesn't change is that the ecosystem around that changes. So we will have new vulnerabilities coming out. We will have new versions of software coming out that fix those vulnerabilities. But if we have an immutable container, those changes are not going to be automatically deployed to our clusters. So that means that insecure code stays basically in this time capsule. And if you have, say that you have this microservice architecture, right? Like many companies do nowadays. I've talked to companies that, when they say they do microservices, they think it means like we do 10 services, others do 150. There's no specific number to say when you're doing microservices. It's more of a mindset, of course. But the thing, of course, is also that certain components, they will be stable in the sense that they don't need any updates very often. And that's actually beautiful. But the problem, of course, then is that if they are not frequently updated, that's actually worse for security. So you actually need to keep updating them with the underlying software, the underlying bug fixes, maybe not in your application, but maybe in the components that you depend on. Okay, so what can you do then? Well, obviously, there are scanners for these things. It's essentially like a virus scanner. So it's going to look through the container image that you have. It's going to see what software you're basing your containers on, and it's going to alert you if there are any known vulnerabilities. So the report says, the Kubernetes Hardening Guidance report, it says use an admission controller in Kubernetes. And what is that? Well, an admission controller in Kubernetes is something that catches every single API request coming into the Kubernetes cluster, and it's going to react to it. So either it can do something smart like Open Policy Agent does, like say yes or no, depending on some rules, or in this case, when I try to deploy a new container in a pod via deployment or whatever, it's going to say, hang on, let me just scan this thing first. So that's what the report says. Now, the problem that I see with that is that essentially most people will either just include scanning in their build process, or they will tell their image registry to scan upon pushing that image, or like this report says, use an admission controller. Now, how long is the time that passes between the container being built, being pushed, and then being deployed to the cluster? That's a matter of minutes. So who cares? The problem is if something stays in your cluster for weeks, then what? Because it's not getting redeployed by itself. So my take is you should daily scan all images that are actually in active use. So you should have something that continuously looks at these things. So if I deployed something 2 weeks ago and then it was fine, but now we know that there's actually a bug in there, that's the kind of information that I want to have. Not just that, it was bug free when I deployed it 2 weeks ago. Okay, so the second point is rather obvious, and it's something that Victoria and I touched upon before the presentation started, namely that both in, say, Docker, but also in Kubernetes, the default settings are basically the most insecure ones you can have. So the containers, they run as root by default, and they really shouldn't. They should be run with the least privileges possible. So there are also... So why does a container get to write anything to a file system unless it really needs to? So you can actually tell your container you have a read-only root file system, and if you want to do reading and writing, well, you're supposed to do that only in this attached persistent volume. So that's where you actually work with data. Otherwise, just read it. There are pod security policies in older versions of Kubernetes. There is this pod security standard in newer version of Kubernetes. You should totally use whichever applies to you. And interestingly, also a security nightmare really, is that when a pod starts, it typically gets this default service account mounted into it, so it gets to talk to the Kubernetes API. Now, most pods are not actually supposed to talk to the Kubernetes API. What's the point? I mean, most applications don't need to actually talk to the API that's managing them. So obviously you should not do that. You should just take that away. You should disable that automatic setting that is just there. And I think that you should also encode your policies for automatic enforcement via something called the Open Policy Agent. So as I said before, that's running as an admission controller. And what it does is that it catches every API request coming into your cluster. Any Kubernetes API request, like here's a new container, deploy it in the deployment, or change config map or whatever contents. And it's going to look through a set of rules that it has. Those are your rules then that you've set in place. And it's going to give a thumbs up or a thumbs down depending on those rules. And if it's a thumbs down, if it's a rejected call, that means that it's not going to be processed further by the API server. Right. So say that we have reduced privileges and we have, contained our pods better. Now let's also make sure that they don't get to network with everything that's running in the cluster, which is also one of those default settings in Kubernetes. So use network separation to control the amount of damage a compromise can cause, is what the report says. Now, the problem networking-wise is that the default settings in Kubernetes, of course, it allows all pods to network with all other pods. And when it comes to security, it's only as strong as its weakest point, right? So if I manage to get in via some front-end container, and from there I get to access every single thing that's running in the cluster, which, by the way, there's this DNS server that's running inside the cluster, which makes it really handy to figure out all kinds of traffic that goes on in the cluster, so it's not that difficult. That's not very good. So you obviously want to have some kind of firewalls in place, and that's exactly what network policies are in Kubernetes. They're essentially Kubernetes-aware firewall rules. So you don't need to speak in terms of IP addresses, although you can if that's something that you want. You can actually configure it in terms of Kubernetes objects. So you can say these pods that are called backend, they get to make calls to these other pods that are called database, but nothing else gets to make calls to database because it's only backend labeled pods that get to do that. So that means that if the pod happens to be restarted on a different node, if you scale up, you scale down, network policies will automatically be enforced and will automatically just work. And that's really nice depending, well, because Kubernetes has such a dynamic environment for running your applications in, right? So point number 4, you should also use firewalls to limit unneeded network connectivity, and you should use encryption to protect confidentiality. So I talked about network policies between Kubernetes objects. Now, you should also, of course, have firewalls in place so that you protect your API server, because why would that be accessible to, say, the entire internet? It probably shouldn't be. What definitely shouldn't be open to the internet is your etcd server, like the brain of Kubernetes, essentially. Controller managers should also not be accessible, etc. And again, security default here. Kubernetes network traffic. So inside of clusters, that's typically unencrypted by default. Is that a huge problem? I don't know. It depends. Do you trust the network or do you not trust the network? So do you trust the network in, a big modern cloud provider? Maybe. You should always have some kind of process for figuring out what your information security requirements are. Now, do you trust it at a co-location place? So you can install Kubernetes anywhere. So say that you just rent space for your servers to be in a co-location facility. Do you trust that network? Maybe, maybe not. I think you should really consider, can I trust the network? And if your answer is no, I probably can't, then you should use a networking provider that can transparently provide encryption when traffic passes between nodes. So within a node, you don't really need to encrypt because, well, then it's just going to be inside that node anyways. But if it's going to cross between nodes, I think you should probably use something that, say, this Calico with WireGuard support. WireGuard being this lightweight VPN alternative, which can add encryption between nodes in your cluster. Okay, so point number 5. Use strong authentication and authorization to limit user and administrator access, as well as to limit the attack surface. Now, as most settings in Kubernetes, I think you're going to get tired of me saying this. So there are things, there is configuration you can enable in Kubernetes to make it more secure, but it's not enabled by default. So authentication actually being one of them. It's on an opt-in basis. Now, if you've installed Kubernetes from scratch or using something like Kubespray or whatever, you have this like administrator configuration file, which makes you like essentially the super user of the cluster. And what I've seen far too many teams do is they pass that thing around over email and everybody is just, the admin user and everything is just super easy and you can access every single thing in the cluster. The problem, of course, is that if somebody was a consultant or whatever and they left, they still have access to the cluster and nobody changes that thing. So obviously, I think you should integrate with a real OpenID Connect, for instance, based system so that you can actually authenticate in a reasonable way. And then, of course, authorization, that's also on an opt-in basis. So Kubernetes provides mechanisms for role-based access control. You should totally use that. You should also disable anonymous access, which for some reason is enabled by default. And you should have policies that restrict permissions as much as possible using role-based access control. So if you have your Google accounts, or if you have, I don't know, Microsoft Azure or Office 365 or something like that, then by all means enable that, talk to it, get your OpenID Connect ticket, which shows, your OpenID Connect token, which shows which groups you're a member of, and then only let members of the admin group actually access the more admin parts of your cluster. You should have some kind of log auditing so that administrators can monitor activity and be alerted to potential malicious activity. So Kubernetes has the API server. You can tell it to enable audit logging. Of course, that's not enabled by default because it's a security setting, and obviously that's not enabled by default. It's also going to create a huge amount of logs because every single API request is going to be logged, and in quite an amount of detail. So you need some kind of automated system for processing these audit logs. Now, I would recommend that you use something called Falco because it can, well, A, it's open source, and B, it can act as a simple security incident and event management system together with some kind of centralized logging, like, for instance, Elasticsearch, which I'm guessing you're running anyways, or I guess ClickHouse, right? So or Loki. But I know the Falco can be integrated with Elasticsearch. So if you have these slides, you can click on the link and you'll see an example of how that's been set up. You should, of course, always periodically review. This is the last point of the NSA and CISA tech report. You should periodically review all Kubernetes settings and use vulnerability scans to help ensure that risks are appropriately accounted for and security patches are applied. Whew, that was a mouthful to say. Now, Kubernetes has a new release that comes out roughly 3 times per year, and they support the current version and the previous ones, which means that even if you want to be as slow as possible with upgrading your Kubernetes, you need to do it at least once a year. And you probably don't want to do it just every third version, a big jump. You probably want to do it 3 times per year. Then you run you run your Kubernetes cluster on some kind of operating system that also needs to be upgraded. And yeah, there's tons of stuff to do. A lot of platform operations, if you will, because it's not really related to the application. So it's not really something that developers are skilled in doing. Not necessarily. I mean, it's not what they really care about. They don't want to do this stuff. It's just something you have to do to provide them with the platform upon which they can deploy their application, right? And as I've said multiple times now, security features are typically opt-in this world rather than opt-out. So please opt in as soon as possible. And there are automated testing tools that you can use that help find insecure default settings. So are those tools sufficient? That's a good question. I think you should totally use them, but you should also be aware of what they can't do. So the 2 main tools that I think are really cool right now for automated testing are Kubescape by Armo Security. It relies on what it can determine via the Kubernetes API. So it talks to the Kubernetes API and it figures out if you are actually compliant with these very standards here, or these very recommendations by the NSA and CISA. They have open sourced that test suite. There's more to their entire product, but that's what they've included in the open source. And there's also something called KubeBench by Aqua Security, and that works a bit differently on a technical level. So it's going to connect more deeply into the control plane hosts of your Kubernetes cluster. So it can actually inspect a bit more than Kubescape can right now. But yeah, it's a completely different test suite. So you can use both, but please be aware that it's the low-hanging fruit of vulnerability scanning. Okay, so my take is that you must do this to make sure that your cluster doesn't scream like, hey, I'm insecure, come hack me now. Because obviously hackers are also going to run these types of automated tools and checks, right? It's not just you, it's them too. But also, please be aware that these things, both Kubescape and Kubench, they're both going to be limited in what they even can investigate, no matter how they actually do it. Because they will not be able to tell you if you have encrypted at rest storage. They're not going to say anything about any firewall rules because they can't see that. They don't know if security policies happen to be encoded in other systems than Kubernetes. So they don't know if you have open policy agents sitting there and doing all kinds of fun stuff. They don't do anything about the underlying operating system. They don't do anything about third-party software, blah, blah, blah. There's stuff they can do. So be aware of what they can do. Use them for that, because obviously everybody else is going to use them for that too. But don't have this false sense of security, like just because you pass all those checks that you're totally fine, because you're not going to be. So let's go beyond the NSA and CISA recommendations, right? So my first point here, and this is all just me. So the previous part, that was all kinds of stuff that was in the tech report, but this is now all me. Okay. Point number one that I want to make: prevent misconfiguration. Don't just check for it. So as I said before, right, 2/3 of all insider incidents being due to negligence means that people in organizations typically have far too many permissions. And in my mind, that's a misconfiguration. So you should lock down your systems better than that. It's also important to remember that while role-based access control is great, it's also limited in what it actually can express. So Lars, well, me, may be allowed to modify configuration, say upload a new configuration map in the production environment. But that means I can put whatever I want in there, and that's not good. So Open Policy Agent can do just that type of checking. So even though the role-based access control would say, yes, thumbs up, Lars gets to put whatever configuration he wants in a config map, Open Policy Agent can say, that password you just tried to set in your config map, that's too weak. Or we have a policy against pushing, AWS access keys into config maps or secrets. Don't do it, for instance. So you have all these tools. You have like Falco. You also have certain cloud providers, like AWS provides this thing called config that checks, are you in compliance with whatever policies that you've set? But I think that running something like Open Policy Agent that will just prevent you from ever being misconfigured, that's so much better. So why even let it happen in the first place? Prevent it. Stop it. Don't allow it to happen. Number two, beware that any permission given to an application is also then given to bad actors. Because if I manage to hack an application, then I have all the permissions and the credentials that it can access. And that typically means all kinds of stuff, like third-party software as a service integrations. If you have a cloud environment that is VPN connected to some back office location, like because maybe you run some kind of database or whatever in your own data center, but you want to run most publicly facing processing in the cloud for scalability reasons. If the application can access that, so can it. It can also do that if it's been hacked, and also various databases, of course. And maybe you think this is not a big problem, but do keep in mind that most containers out there are running as root. They have a full shell and operating system installed, and if they're running as root, when I get in, I can install whatever I want. They have literally no restrictions on what they can do. There's no resource limit, so I can start mining Bitcoins there or whatever. Most don't even have intrusion detection systems in place. And by the way, they're granted full file system and network access. So if you're like most companies, simply getting in anywhere in the cluster means I've gotten into all of it, especially if I can also access the Kubernetes API and start all kinds of new instances of whatever I want because you happen to grant me that access. Remember also that containers share the host's kernel, so there's all kinds of fun stuff you can do there too. So that means that you should always restrict your application components as much as possible. Because honestly, if all a component is doing is it's listening to incoming calls over some, I don't know, some REST API, why would it ever get to do more than take in those requests, process them, and then send back responses? It shouldn't do anything besides that. It shouldn't have any permissions to do anything else. So please limit the amount of permissions that you give, both in terms of what it can actually do inside the kernel, but also over the network. Number 3, you should keep cloud resources specifically in mind too, because what I see also is that, all this DevOps stuff is difficult. So many prefer to run various controllers, various operators in the community. They offer some kind of nice cloud integration. Now, the question is, how seriously do these components take cloud security? Most, not very. And I think you should outright reject ones that don't have configurable and restrictive permissions on what they manage. And especially, you should throw out anything that fails to list exactly what permissions they need and document why they need it. So, in a cloud like Amazon, you have this IAM permission system where you can, on a very fine level, say exactly what kind of permissions you need to perform certain tasks. If you're running a component that integrates with AWS and you don't have that in place, if the component doesn't list exactly what permissions it needs, it's probably not a very secure component. It's probably not something developed by somebody that has a very good security mindset. So reject that. Don't use that. Also, if you can't configure exactly the security settings, like is my contents in this S3 bucket going to be public or not? Can I limit who gets access to it, etc.? So if you can't do that, it's obviously also not a very good integration. So please keep that in mind. The next one is even worse. The next one is this. Does your application unintentionally have permissions in your cloud? Because that's actually true in far too many cases. What does this mean? Okay, well, for automation purposes, it's very convenient to let your cluster nodes do things in your cloud acting on your behalf, right? So I've seen people set up their cluster nodes to be able to do, say, modifications of auto-scaling groups so that the cluster can increase or decrease in size, or that they have access to DNS records so that they can update, like, oh, I deployed a new service here. I'm going to update my DNS records in the DNS service of the cloud. Load balancers can be created because how else do you want to expose services and stuff like that, right? So there are all kinds of nice integrations. The problem is they rely on just the identity of the server being that the server, the virtual machine, the server there, talking to the cloud. Now, if a piece of software is running in a container, that's also that server. So what you can do in far too many cases is you just call the cloud's metadata service and you get a token that gives you permission, and then you can do whatever that server was allowed to do. So that means if I manage to hack into your application and that runs on a server that gets to, say, scale the cluster up and down, now I can scale the cluster up and down. That's not very good. So applications are also the virtual machine according to what the cloud can determine, because there's nothing that separates it. It is running on the virtual machine. So that's a bit scary, right? So if you can scale your cluster up and down, so can I. And maybe I scale it up a lot and then I start I don't know, mining cryptocurrency on there. So beware of that. This point I already said, but I'm going to make it again because I think it's really important. And I've seen so many companies that just do scanning upon pushing to the registry that I get a bit scared. So I think that you really need to regularly scan all your deployed container images, not just when they are new. Okay, so how do you actually do this? So to get up-to-date security scans, I think that all you need to do is you need to loop through all the pods that are deployed. And in each pod, there can be many containers. Typically, there's like one, but if you have sidecar containers, you can have more than one. So then you determine which container images are actually in active use right now, and then you tell your registry to scan those images again. And you can do this daily. So a lot of cloud services, you can trigger a scan manually, essentially via an API call. So do that. It costs a bit of money, yes. If you think it costs too much money, you can host a registry yourself. It's something that we do in Compliant Kubernetes. Again, that open source Kubernetes distribution. So there's an open source container registry called Harbor. You can use that. It integrates with a vulnerability scanner called Trivy. It's really good. Then you can just do this whenever you want because there are no limits. There's no like budget limit to how often you can tell it to do work. And this will give you something that is much more secure than both the scan on push, which is now becoming more of a standard in all registries, but also the scan on deployment that the tech report talked about. So I think that is something that you really need to do. So please do scanning. Because I mean, if we're thinking about this as, say, virus scanning for a desktop computer, you wouldn't just do that once, right? You'd do it continuously. So why would your servers be different? They shouldn't be. Point number 6, regularly have your own staff security test your entire system. That's something that I think you should do. So we all know, I mean, as people that develop software, that building is hard, but breaking is easy, and it's also fun. And something that your engineers have, but hackers don't, is access to your source code. So your engineers probably have a pretty good idea what parts of your infrastructure maybe aren't the best. So maybe something that can be improved upon. So please let your engineers try to break your application, because it's always better if they find any errors than if hackers do. This is something that I've tried at various companies, and I've always had a lot of fun with it. So one of my favorite stories about this is a company where we developed this system for managing stuff. So whatever it was, let's not get into it, but you could group things, and you could group things not just like in say a folder structure, but you could also have like subfolders in that. So the problem there was that when we designed that, it was obvious that the idea was only to have a few layers of folders, or maybe just one. But what I did during one of these, like, yeah, let's try to break the system types of days, was that I just used my laptop against the deployed production service, or maybe it was a testing service, I don't know. But against, the deployed system, I just ran a simple script where I created nested folders in each other, say 1,000 levels deep, when most tests had only been like 3 layers deep before. And that showed that it was very easy for me, just using one laptop, to like denial of service attack the entire system. So that's pretty scary, because that's something that you probably wouldn't find during unit testing, because there it's just it's your computer, which is probably plenty fast because you're a developer, you're probably not testing 1,000 levels deep. You're probably just doing like, can I make nested folders? Yes, no. That's a unit test. Done. So you really need to try to actively break stuff as well. And I think that most people that get into engineering, they have a bit of a devil inside them that thinks it's a lot of fun to break things. So if that describes you, then release that devil a bit. Ask your boss for permission. But I think if you're that boss, you should tell people that they are permitted to try this, say once every quarter or something. Have like one day or one half day when people just get to go nuts and see if they can find any security issues in your system. Because this fosters also a security first mindset, and you really want that, because the problem is that when we're developing things, security always is this feature that comes afterwards, right? And obviously that's been true also for Kubernetes and Docker and stuff like that too. That it's been developed, it's working. Let's not enable security defaults because that would be annoying. Okay, and that's not very nice. So we should have a security first mindset always. And this is the way to get it all into the roadmap so that people actually take it seriously. Point number 7. You should always have a disaster recovery plan. You should always actually practice it as well. And please be aware that disaster recovery does not equal backups. Okay? Having backups is necessary, but not sufficient for disaster recovery, because a disaster could be an entire cloud region going poof. Okay? Not just one availability zone, the entire region. But it could also be that you've been hacked and you need to go back in time to like 5 hours ago before an attack started. So how quickly can you destroy your entire infrastructure? Because if you got hacked, you can't trust anything anymore. So how quickly can you destroy your entire infrastructure and get it back again? Well, minus hopefully the security incident, that the security hole that they got in through. And how quickly can you also rotate credentials in all your systems? My guess, based on the people that I've talked to, is that these are really uncomfortable questions for most people in the audience. Because destroying the entire infrastructure, getting it back, putting all data in place the way it was, say, 5 hours ago before an attack started, that's not easy. That's definitely not easy. So if you don't have a plan for this and you haven't practiced it, you will probably not be able to do it that quickly. And then it will be very tempting to just keep going with the system you have, hopefully just patch things up, and then hope that nobody gets in again. But you have no idea of knowing that's not going to happen. They can have put backdoors in there and you have no idea. So you really need to think about, how can we destroy everything and start it all back up again and restore from, yes, I'm going to say the word, restore from backups, so that you can actually get back in time to, say, 5 hours ago before the attack started. Yeah. Disaster recovery. It's actually a very good idea. Something that's also a very good idea is the fact that you should totally use both an intrusion detection system and a security information and event management system. Okay, so what, you know how I said that it's better to prevent misconfiguration rather than checking for it afterwards? And sure, that's true. But you need both, because both intrusion detection system and, this security information and event management system, they're about protecting you against the unknown attack vectors, because you don't have a policy in place against unknown. And an intrusion is likely due to some exploit or vulnerability, not something that a policy, could have prevented, because your policy doesn't say write vulnerable programs, obviously. So what you need to do is you need to have something that verifies that your applications, they actually behave normally. What does that mean? Well, that's totally application dependent. But it can be stuff like, my application typically reads and writes to files in this directory. And if it starts to read and write to things outside of that directory, that's probably because somebody is trying to hack it. Or we have this policy in place that says we do all kinds of debugging using only logs. So if somebody ever goes into a pod and tries to execute a new container in there, that's probably somebody that hacked it. Or, you know, starts a new process. It's only supposed to be one process running in this container. If it's more than one, that's weird. So something that behaves in a not normal way, you need to have a system in place that would find that and would stop that. And with tons of logs, you also need something to sift through those logs. Obviously, it can be false positives. It could also be indications of actual incidents. Now, Falco, as I said before, that's open source. It's been developed by SysDig, and it's both an intrusion detection system, and it can also be a simple security information and event management system. So by all means, use it. Everything that I've talked about here is always going to be open source because I'm all about open source. I mean, not just the Kubernetes distribution that we make, this compliant Kubernetes thing, but everything that I do, I always try to do open source because I really believe that that's the best thing for security. Otherwise, how can you really trust it? I mean, obviously, am I reading through every line of code that is in my system? No, I don't have time for that. So I too trust third parties to have done this for me, essentially. But just the fact that I can really helps put my mind at ease. So I like open source. It's wonderful. How about a summary of what we talked about today? So I think the main message that you should take home is that Kubernetes is neither safe by default nor by itself. Okay, so it has all kinds of nice security features in it, but you really need to enable them. And additionally, you need to restrict access in terms of both the network and users, what they can do, in terms of machines, what they get to do, and all kinds of privileges as well inside those systems. You should periodically use tools that assess your current security practice. You should prevent misconfiguration. You shouldn't just check after the fact if everything is okay, because then there's this time window where you had insecure configuration in place and you weren't okay, and that you discovered that you weren't in an okay spot. And that's not good. So prevent rather than checking after the fact. When it comes to cloud resources and permissions, just please be mindful that those exist as well and that those can be problematic. You should do whatever you can to foster a security conscious engineering culture. So try your own application, test it, try to break it, and try to break it often, because hackers aren't going to give you like time off. They're not going to wait until, this sprint is over, or, when it's convenient for you to look at security at this huge backlog of issues that you probably want to ignore. No. Please have a security conscious and security first, possibly even, mindset. Because it's just really getting embarrassing how often we find in the news, like, oh, here's this S3 bucket that was publicly accessible to the entire world, and it had all kinds of like patient data or whatever on it. It's just getting, pathetic. So don't be that company. Also, disaster recovery. Practice it, because it really should apply also to security breaches. Okay, so let's get back to that uncomfortable question then. The one I asked in the beginning. The one that maybe gave you sweaty palms and this worried look on your face. What permissions have you given me in your Kubernetes cluster or cloud infrastructure if I manage to hack into your application? Well, after today, if you actually take all kinds of advice into consideration, I hope your answer will be something like this. No more than absolutely needed, and that you will see that I'm there because you have automated systems that both limit what I can do and also raise an alert when I make the application behave in ways it doesn't normally do. So if I find a new cool way of exploiting your application, that's supposed to be flagged behavior that you can easily find your logs, you can easily get alerted, and it's happening in an automated fashion. And maybe you can also automate kicking me out because you just restart the container that I got into somehow. And maybe that's going to make it difficult for me to get back in because I relied on some memory allocation bug or whatever. And I can't really recreate that so easily without all kinds of other logs screaming as well. So, if you have any questions for me, then either I hope you've written any here in the chat box of this presentation, or there's going to be a Q&A session right after this talk. If you don't have time for that because maybe you want to head to a different session, or you just haven't quite formulated that question quite just yet in your mind, then you can send it to me via email. It's lars.larsson@elasticist.com, or you can connect to me on LinkedIn, and let's keep the conversation going there instead. Right. Thank you.
Yeah, thanks, Lars. There was a lot of the information to digest, and actually, we got a few
Oh, wonderful.
questions.
Yeah.
Taking into account the time, let me ask the
Sure.
one, and let's continue with other questions on
Yes.
our discussion
Sounds like a
panel.
great idea.
So, wow, I'm just like trying to pick the lucky one
Yeah.
as a first. Um, what do you think about the house engineer? Can it be helpful because of the
Sorry, what now?
recreating pods? Or what do you
Oh,
think about chaos engineer? Can it be helpful because of
chaos
recreating pods?
engineering, for people that maybe aren't aware of what that is essentially that you have something automated running inside your cloud deployment or inside your cluster, and it basically just shoots down and like tries to cause crashes and basically just creates chaos in your deployed application and sees, can it actually survive this? I think that's a wonderful thing to do. It's something that really proves the stability of your system. So it's something you should do to see that you can survive an outage. It's definitely worthwhile. It's related to security in the sense that if you have one like single point of failure, and that can be taken down by, say, a denial of service attack, and your entire application just falls over because that component is now crashed or gone, that's really bad. Uh, it's not something that will necessarily try to find vulnerabilities for you in your deployed application, but it's something that definitely shows if you have an application that is resilient against failure, and I think that's something you definitely should put in place. So yes, that's awesome. If you have that, then that's wonderful.
Yeah, and I can't agree more on that answer. Actually, I'm as well like quite a huge fan of house engineering.
Yeah.
It was like I said, it was a teaser. Let me ask other questions in our discussion panel, and let's meet you there.
Yeah.
And so for now, see you there.
Yeah. See you.